Hello, everyone. In this video, we're going to look at our final example in section 3.7 on business applications. So let's go ahead and read through the scenario before beginning work on the problem. So this problem says a company is considering purchasing a new machine for its production floor. The machine costs $65,000. The company estimates that the additional income from this machine will be a constant $7,000 for the first year, then will increase by $800 each year after that. In order to buy the machine, the company needs to be convinced that it will pay for itself at the end of 8 years with this additional income. Money can earn 1.7% per year compounded continuously. Should the company buy the machine? So this money that is compounding per year continuously is the money that the machine is earning. So that's why this rate here is going to be involved in our problem. So what I'd like you to do is pause the video and reread this scenario for yourself, make some notes, and have it make sense to you first. Okay, so now let's look at it together. So a few things that are going on here is that first we can highlight how much the money, or highlight the function that tells us how much money the machine is bringing in. So we're told that the machine will bring in $7,000 for the first year and then $800 per year after that. And we're looking at the situation for 8 total years. So the interval that we're looking at would be from 0 to 8. And in that time, we have our function, our income function, f, we'll say f sub 1 of t, is going to be 7,000. And recall that's just coming from that first year. So that would be the interval from 0 to 1. And then forever after, or at least for the next 8 years, we'd have f of t is going to be the original 7,000 plus $800 per year. So here now, time is going to be t minus 1. And that's because if we start at just t here, if we don't have this minus 1, then if we plug in 2 years later, that will be as if we had 800 times 2. So that would give us 800 for the first 2 years, but we only get 800 for the years after the initial one. So here we have from the interval 1 to 8. And we'll write that with green here, so it's different from the function. Okay. So what we can do is just work out this function a little bit more to simplify it. So we actually get here 7,000 plus 800t minus 800. So we can just combine those 7,000 minus 800. So we're actually going to get 800t plus 6,200. Okay, so we have 2 income functions that we're dealing with. So we need to set up the integral for finding the present value using 2 integrals. So we'll first look at the integral just from 0 to 1 years. So for that, that will be this f sub 1 of t, which would be 7,000 times e to the negative 0.017t dt. And to that, we're going to add then the integral from 1 to 8. So that next time interval here of our function here that we just simplified. So that would be 800t plus 6,200. And that is all going to be multiplied by e to the negative 0.017 t dt. So just to summarize here, this first interval, or integral rather, is going to tell us the money that the machine will bring in from the first year. This next integral will tell us the money that the machine will be bringing in, and not just the money it's bringing in, but the interest in addition on that money the next 1 to 8 years. So what we can do now after setting up these integrals is use our calculator to compute them. So what I'd like you to do is pause the video, and I encourage you, you can either work out these integrals by hand, maybe using some U-sub or integration by parts, or feel free to use your calculator. Again, the focus on this section is on our business applications. So that's where the priority is here, is setting up these integrals. All right, so I'll let you pause the video and then we'll look at it together. All right, so I'm going to open up our Desmos calculator, and we can feel free to follow along if you want to see how we would compute this integral on our calculator. It can be tricky the first couple of times, so it's good to go through it together. So when we're doing that integral, I just type in INT and that integral symbol will come up. So our integral goes from 0 to 1 at first. And then we have our 7,000 times e to the power. And I'm going to do some parentheses here so that everything is in that power. So negative 0.017 times t. In parentheses there. And that's a dt. I go back to my letters, dt. And then to that, not done yet, I'm going to add the integral int, lower bound of 1, upper bound of 8. Here I'm just clicking to get into those upper and lower bounds. And then I have the integral. I'm going to use a lot of parentheses here, 800 t, and plus 6200 times e to the power of, again, lots of parentheses, negative 0.017 times t. Okay, so now I need to end my parentheses here and finish up with my dt. All right, so here we are getting 70,165.916. So we can round up to the nearest dollar here. So I'll just round up to 70,166. So let's go ahead and write that on our notes. So this is about equal to 70,166. So take a moment to just reflect on what this number means. So this number means that we should expect our machine, if we were using it, to bring in an additional $70,166. So this is how much the machine will be bringing in and how much money we will get on interest for that money that the machine is bringing in. So is it worth it then to buy the machine? The machine itself costs I'll highlight here, costs $65,000. In 8 years, the machine will have brought in $70,000. So yeah, it seems like it'd be worth it. So this cost of the machine, so we can say yes. The company should buy the machine. And why is that? Well, the present value of machine is 70,000 is less than the cost. Awesome. All right, everyone. Thanks for watching. Keep up the hard work.